Right, we are going to be having a look at circles. We are going to name the different parts of circles. So if we have a look at this particular circle, the area that I have already drawn, or the part of the circle that I have already drawn, is called its circumference. So when we are working with squares and rectangles and triangles, we call the outside part of them, we call that the perimeter. But with circles, we call it the circumference. So what is the circumference of the circle? That is what is the outside. So how long is this outside bit? Right. Let's have a look at our diameter. The diameter runs from one edge of the circle to another edge, and it crosses through the center point. So let's put the center point here in purple. So that is the center of our circle, and the blue is our diameter. So running from one edge of the circle to another edge of the circle and through the center is called your diameter. If we have got a line running from one edge of the circle to another edge of the circle, that is called the chord, or it is called a chord. Right, so your diameter is the longest chord in any circle, because any chord just runs from one point or one edge of the circle to another edge, and it doesn't run through the center. But as soon as we have a chord that runs through the center, it is called the diameter, and your diameter is the longest chord in any circle. Right, then we have a line that runs from the center of your circle to the edge of your circle, and that is called the radius. So the radius of your circle runs from one edge of the circle to the center point of your circle. Now what you will notice is that your radius is half of your diameter, because if I run from one point of my edge to the circle, to the center of the circle, I end up with a radius. And if I extend that radius to the other edge, another edge of the circle, I will end up with my diameter. So your radius is half the diameter. Right, then we've got a line that just touches the outside of the circle, so it just touches the circumference of the circle, and that line is called a tangent. So the tangent is a line that runs it doesn't enter the circle, so it doesn't cut through the circle's edge, but it just lies on the circle's edge. It doesn't actually cut through. Then we've got a line called a secant, and a secant does pass through the circle's edge. It cuts the circle's edge, or cuts the circle's circumference at 2 points, there and there, and that line there is called the secant. Right, so these are some of the parts of the circle. We've got the center point, we've got the radius, which is half of the diameter, we've got the diameter, which is double the radius, we've got our circumference, which is all the way around the circle, we've got our chord, which is from one edge of the circle to another edge of the circle, and remember that your diameter is the longest chord in any circle. We've got the tangent, which is a line that runs right next to the circle and just touches the circle's circumference. It doesn't actually pass through the circle, so it doesn't cut through the circle's edges. But a secant does cut through the circle's circumference at 2 points, and that is called, so that line there is called the secant. So these are some of the parts of your circles. Right, we are going to have a look at some other parts of our circle. There's my center point. If I go from my center point to one edge of my circumference, I have a radius. And if I draw another radius there, what I end up with here is a sector. So a sector is bound by 2 radii and an arc. This part here, so any part of the circle's circumference, is called an arc. So we also have an arc over here. Right, so if I draw a chord from one edge of my circle's circumference to another edge of my circle's circumference, this region here, bound again by an arc and a chord, is called a segment. So this segment is, we could call it the minor segment. And the reason for that is because this chord, we can also use, obviously there is also let's use a different color. There is an arc, a much bigger arc, which we will call the major arc over here. So that big arc there is called the major arc. And this smaller arc here will be the minor arc. And this is the minor segment because it makes up a smaller part of our circle than this area here. So that would be called your major segment. But for now, I think all you really need to know is that a segment is bound by a chord and an arc. So your arc is just any part of the circle's circumference, any joint part of the circle's circumference. A sector is bound by 2 radii and an arc, and that's a bit like your slice of pizza. And a segment is a segment is bound by a chord and an arc. So this is the segment. Right, if we have a look at pi, we need to understand what pi is. Pi is the ratio of the circle's circumference to its diameter. So it's the ratio of the circle's circumference to its diameter. Okay, and pi is an irrational number. Okay, and an irrational number means that it has an infinite number of decimal places. So if we have a look at pi, it starts off with 3.14159, and it will just carry on with no particular pattern for a very long time. So it has an infinite number of decimal places. Remember, decimal places are the numbers after the decimal point, or the digits after the decimal point. So pi is an irrational number, and pi is the ratio of the circle's circumference to its diameter. So we use pi when we are working out the area of a circle. So the area of a circle is equal to pi r squared, and r is your radius. So you square your radius and then you multiply it by pi. So obviously, because pi is an irrational number, we are often asked to use pi equal to 3. We'd probably first start with pi is equal to 3, or when we move on, we might use pi is equal to 22/7, or pi is equal to 3.14, which means we've just rounded it off to 2 decimal places. So those are your different options for using pi when we are working out the area and circumference of your circles. So the area of a circle is equal to pi r squared, and the circumference of your circle is equal to 2 pi r, or pi times your diameter. Because 2 times your radius is equal to your diameter, because your diameter is double your radius, we can use either of these formulae. It doesn't make a difference. Right, so this is how we would incorporate pi into working out the area and circumference of our area working out the area and circumference of our circle.